We feel good. And how is the weather? Very nice weather. Wonderful. So we started on Monday to train on managing road infrastructure assets for sustainability. Day 1, Monday, day 2, Tuesday, day 3, Wednesday, and then we are finishing today, day 4. Can somebody just tell me their experience? How has it been? Just tell us. Use your voice louder. Let's just hear. One man, one woman. Let's balance or do gender equality now. So just tell us, how have you felt and how are you feeling today that the training wants to end? What do you want? Are you happy about the training? Do you want us to continue, or you are happy that we are finishing today? Let's hear you. Ladies first. Tell us. Let's hear that sweet voice from the ladies. So tell us, how have you felt? What has the feeling been? So that we'll know if we should continue the training or we should just close and go home. Who is going to bail us? Keystone, you want to say something? Say it is in your mind. Just say it. Oh, she feels like a civil engineer. That's wonderful. Okay, so from the men, are you feeling like a banker? Wonderful, one word. That's awesome. Thank you very much. So without taking much of your time, can we just be upstanding? We'll pray and then we continue to the training. So together we pray the third stanza of the national anthem as our opening prayer. O God of all creation, grant this our one request. Help us to build a nation where no man is oppressed. And so with peace and plenty, Nigeria may be blessed. Amen. Thank you very much. Let us have our seats. So today, what we shall be having, we'll be having techniques for enhanced roadway resilience. And then after that, we'll have our coffee and tea break. And then we shall be having preservation techniques for enhanced sustainability, and then how to assess and evaluate life cycle costs of roadways under different construction/maintenance scenarios. Then we'll go to the closing ceremony where we'll have the award of certificate presentation. But before we continue, I'd like to apologize on behalf of the institution for starting this training, not exactly at 9, though we started in our minds. We were here, and then we are starting now, a few minutes later. Thank you very much. So once again, I'd like to appreciate every one of us and recognize the immediate past national chairman who is here and has always been here with us, Engineer Saidu Hassan, FNSC NIHTE. Let's put our hands together for him. And we have also here present a past national chairman. He has been here all the time and very early and will wait till the end. Every one of them, Engineer George Nsonwu, fellow of the Nigerian Society of Engineers and NIHTE. And we have the pioneer chairman who, I don't know where he gets his energy and strength from, but he happens to be the chairman of the planning committee of this training workshop, Engineer Isa Osman Imwabinu, FNSC NIHTE. We have a member of the board of trustees here of NIHTE, our very own director emeritus from FEMA, Engineer EUTB, NIHTE, FNSC. And then we have our very strong stakeholder, especially when it has to do with infrastructure, has to do with roads, a past commissioner of works, Benue State, past Executive Secretary of NSC, past Registrar of Koren, past Vice President of the Nigerian Society of Engineers. You can see he's an institutions person and a professional to the core. Let's make welcome Engineer Felix Atumi, Fellow of the Nigerian Society of Engineers, Fellow of the Academy of Engineering, member of the National Institute. You are welcome, sir. And then you will agree with me that these two persons have been doing awesome since Monday until today, where we'll be having more from them. We have our very own Dr. Amin Aknok. Let's put our hands together for him. Thank you very much. We've been enjoying your lecture, sir. And then we are happy to have you. And then we have from Ghana, our very own engineer, Dr. Patrick Amo Bekwe. Let's put our hands together for him. Thank you very much. And every one of us here, we are welcome from Keystone Bank, from NIBRI, from FEMA, Koren, Federal Ministry of Works. Okay, IRF has one representation here, and they're always online, from RAMP, every one of you, even from the private sector. And our friends from Ghana, one is wearing his Ghanaian dress today. Can you just stand up? Let us see you. That's the yes. And I told you are not going with it. When you finish, just go and get it for me. Okay? Thank you very much. So every one of you, we appreciate you. So we'll continue now. Make way. Let's appreciate Make Way so that nothing will happen to our videos, our whatever today. To be clear, Make Way, we appreciate you. And then to the registration team, the administration department, thank you very much for your work. We remind you once again, ensure you have written your name clearly as it will be on the certificate. If you are not on the WhatsApp group, join the group, very important, so you can get a lot of freebies we are giving up there. Thank you. So our safety precautions and procedures remain the same. Our exit points, just 2 of them. Our cafeteria is at the top, the lobby, and the gallery, and our restrooms just behind me. We already know the drills. Muster point just at the car park. If you need anything, you can talk to us. Keep yourselves hydrated and just follow some little cautions, especially as regards your personal belongings. Thank you very much. So without wasting much of your time, we'll go to the first training for today. The training will be taken by Dr. Amin Aknok, and the topic is Techniques for Enhanced Roadway Resilience. Let's put our hands together for him as we begin. You're welcome.
Thank you. Good morning, everyone. Smiling faces. You remind me of how I look on a Friday afternoon, because I know Saturday and Sunday are weekends, right? So I'm glad everybody's happy. I hope you've taken advantage of the training. I hope you find some good information or, some takeaways that would benefit you in your immediate career or, forthcoming career, whether you do the business in the industry, work for the government, planning on a master's or a PhD. There is always something to learn every day in life. So without longer introductions, I would like to talk to you today about resilience. What can we do to avoid problems? Type of problems which we can see, and what are the adaptation methods which can protect our roadway network. There is always a chance, no matter how the design is good, how the contractor is great, how quality control is at best, there are always a problem or a chance of having a problem, especially with the huge increase in population, huge increase in the number of vehicles, huge global environmental changes. Just the main example I like to use now is what happened in the United Arab Emirates or Dubai few months, almost a year ago. You know, Dubai is in the heart of the Arabian Gulf or Persian Gulf. It's very hot. Rain is something you might see once in your lifetime for a few seconds. They really celebrate rain. So when they designed their highway network, you know, Dubai always sell themselves as, you know, pioneers in everything. The highest, the greatest, you know, the highest building on earth, Burj Khalifa. One of the largest, if not the largest, aquariums is the Aquarium of Dubai. Largest dancing fountain, the one in front of Burj Khalifa and Dubai Mall. One of the largest malls, or the largest mall, Dubai Mall and the Emirates Mall. Some of the best roadway networks designed according, you know, to the state of the art, well preserved, well maintained. Everything is monitored by GPRs, by LiDARs, artificial intelligence, drones, you name it. Anything we talked about, they really take care of. Advanced design series, enough trainings left and right, spending money like crazy. But you've seen what happened a few months ago or a year ago, where due to environmental changes, they had an unprecedented amount of rain, right? So what happened? The bottom fell. The best highway network is gone. Major streets were flooded. People started screaming. There is a major picture that made itself, or a video actually, where one of the main tunnels in Sheikh Zayed Road, the road extending through the whole Dubai, he was going down the tunnel, the water was making a pond. And he suddenly felt the water is gonna submerge him. So they climbed on top of the roof. And somebody walking up, he noticed there is a car stuck down. So he jumped like a diver from top and he started swimming to grab, you know, there was a lady on the roof and having a baby. And it made itself in the news, and, you know, coincidentally, the guy was an Egyptian expat, so in Egypt they took it and, you know, see how expats are and how they are good. But it was, to me, it's a symbol of how, you know, infrastructure, no matter how well planned, how well constructed, there is always a chance of having problems. Now, in the US, the terminology, they used to speak about materials, or when they talk about quality of something, let's say quality of concrete. Fresh concrete, lots of tests. The main one is slump test, right? You measure the slump, it's a measure of workability, the most important property for fresh, non-hardened concrete. Once it hardens, there is still a lot of properties, but who cares, or who talks much about tensile tests, or modulus of rupture, or modulus of elasticity? Everybody predominantly talks about compressive strength at 28 days. So this is hardened concrete. Then after this, everybody started to talk, well, what about durability, which is long-term? So there are two terms when you do superior concrete, and that I learned when I was like 20 plus years ago when I started my master's, and I used the two terms synonymously: high performance and high strength concrete, HPC and HSC. And then one day my advisor came and he said, "You're doing a big mistake. Who told you that a high strength concrete is a high performance concrete?" So I took a step back, and it's like, you know what, you're right. It could be very strong, but not durable. Because durability is a measure of longevity. It could be strong now. In a couple of years, it may not be because of internal chemical reaction like ASR, alkali silica, or alkali carbonate. So it could be strong, but not durable. The opposite is not true. It's very hard to have an unstrong but durable, right? So you better distinguish between strength, an immediate measure, and durability, which is sort of a long-term measure. That was 20 years ago. Over the past couple years, the term resilience came in. So what do you think in your minds resilience could be? I've asked this question, I know, before, and I always like to ask it in any course I teach, regardless to the topic of the course, because, you know, 10 years ago, everybody was talking about green sustainability, and still, and, you know, reducing carbon footprint, recycling. There is always, every decade, a new term pops in where a lot of money, a lot of governmental attention, a lot of research and publication goes into. So the term of this era or this decade is resilience, and I'm glad on the Nigerian society here you take it serious. So it's like when we say AI is a new technology, well, but in our field, talking about materials, we have to know what resilience is as a term. So what strikes your mind when somebody mentions resilience? Can we have a quick open discussion? Anybody? Yes, sir.
Something that can withstand a failure or stress.
Withstand, I cannot say it's wrong. Yeah, that could very well be right. However, the way you phrased it, it sounds more towards durability. Like withstand on the long term. If it withstand immediate stressors, that is strength. Some environmental factors along the way or long-term fatigue or what, that is closer to durability. But I mean, I cannot say again it's wrong. That's right, but it could be missing some fine-tuning here. Huh? Adaptability that augment the, that is the word I'm looking for. Usually resilience, it is a measure of how you can get back something you lose. You know, like let's say a soccer player, a football player, he got injured. Will this injury take him a whole season not playing, or will he rebound in a month? The faster he rebounds and get back to normal after the injury could be a very good measure of how resilient this person is. Does this? So again, strength is immediate resistivity or ability to withstand immediate stressors. Durability on a longer term. How good or what will be the strength in 10 years, 15 years, 20 years? Will it deteriorate? If it didn't deteriorate much, then it's durable. But then if you bombard it, normally by a disaster beyond the control of the designer, a massive tsunami, hurricane, you know, very high speed wind, excessive rain, floods, wildlife fires, huge, you know, seismic activities, something that is not even a terrorist attack, explosion. And then the ability to restore the functionality is a very good measure for resilience. Again, I cannot say this is 100% adopted term, but to my knowledge, majority of the states now, including where I am, they define it like this. And you know, when I was in the UK on the Chartered Institute of Engineers having some meetings there, I find the same exact term. Then I was doing an IRF training about a month ago in Tirana, Albania, for the MOT, the Ministry of Transportation of Saudi Arabia. They sent their engineers, and I was there. And then we had a delegate of 5 people from the Ministry of Transportation of Albania, and their boss, who works on a $100 million project funded by the World Bank. He asked me if he can come and do 50-minute presentation about all the new projects in Albania. And I said, yeah, fine, we're all learning from each other. And then he started speaking about resilience, and then I raised my hand and I said, how do you define resilience here? So he laughed and he said, I was about to ask you how you define resilience in the United States, because we have no term or no exact definition of resilience in Albania, but we adopted what the Chartered Institute of England is doing, which is, I told him, yeah, I know what the Chartered Institute is. So back to our topic, please guys, if you can upload, it's the first presentation of day 4. Excellent. So techniques for enhanced roadway resilience. Basically, how can we make our roadways, and by the way, that could fall, the same definition, everything here can fall on anything included in infrastructure. Remember, the first day when I showed you the website for the ASCE, American Society for Civil Engineers, there is multiple things that fall under infrastructures. Some of it are transportation infrastructures, which is, roadways, bridges, tunnels. It could be power lines, could be drainage, national parks, aviation airports, railroads, phone cable. Anything that makes the country up and running is considered an infrastructure. So all what we are talking about today can fit any type of infrastructure. Of course, roadways, you have adaptive or adaptation techniques. Usually you use the term adaptation to see what procedures you should follow to increase or enhance your resilience or minimize the negative impact of catastrophic incidents on your infrastructure, whatever it is. So in today's meeting, we're dedicating this to the resilience of roadways. Now, it can be defined, and by the way, I'll focus a lot during the presentation on LVRs, low volume roads, because this is on the rise in the whole world, including the US, because normally on our major interstates or freeways or even arterials, we usually follow stringent design techniques or standards and quality control things. But on low volume roads, because of lack of funding and because serving minimal number of people, usually it comes very late on our attention. So there is not a lot of standards being followed. So when there is any hit, they are on the forefront of the damage. And I was lucky yesterday when I was working, and then I talked to my wife. I was working at the hotel, and I asked her about our elder son, how he's doing, and she said, oh, he's in the ARAN today, the Automated Road Analyzer. He works for NCDOT. I was like, what is he doing in the ARAN today? She said, well, you've heard about the massive rain since you left to Nigeria. I said, yeah, I'm following the news, but what happened? She said there was a massive failure on I-40, that's Interstate 40, which literally takes me from my house to the highway. I said, so? She said, well, talk to him and he will send you the pictures. And then I talked to him and he said, why are you awake at 11 p.m.? Or I said, well, I'm just reading and studying. And he said, okay, so what can I do for you? I said, I need you to tell me what's going on the I-40. It's He said, yeah, Mama told you? I said, yeah. He said, oh, blah, blah, blah. I'll show you the pictures. So once he said, what happened? Okay, go ahead and send me the pictures. He said, okay, go to sleep. I'll send it tomorrow. I said, no. I have a presentation tomorrow. You just, hit it on the right time. I need to show the pictures. So I got a few of the pictures, and I'll show you what exactly has happened. A state-of-the-art highway, but they didn't account for specific disastrous events. Literally, they lost tens of millions of dollars just because of ignoring a simple factor. So strength didn't help, durability didn't help. It is the resilience that they ignored, and they are paying a dear price. Cost, time, public roar, because it's a major road that they had to shut. I don't know how they'll manage it. So I'm scared myself, because I used to go to the airport in like 80 minutes. I think it will take me 4 or 5 hours to go to my home with this road or highway being closed. So back here, I think the third line, that represents the major or the most important one. It is the consideration of the entire asset life cycle. When you talk about resilience, you're not talking about immediate design, neither preliminary, neither final, not even the construction or constructability or quality control. Of course, the better the design, the more likely you'll have a resilient infrastructure. The better the contractor, the better the quality control. That all are plus points. But as I said on my example just a few seconds ago, I'll show you the picture of that highway, state-of-the-art design, very wide lanes, excellent pavement, all are gone. So Rationale for preservation, and I'll mention in a minute what's the correlation between preservation and maintenance versus resilience. But generally speaking, on the life cycle, as I stated, resilience is related to life cycle. So initial design is not the only factor, as I just mentioned. Quality control is not the only factor. We have to add any intervention that happens during the life cycle. So basically, we are trying to achieve the highest possible service level, ensure that the funds available are used in preventative actions, not only corrective. That is what we talked about yesterday, and the next presentation after this one, we will be talking about different types of preventative actions and their impact on the roadway network. Timely action, again, as I said, one of the main advantages of pavement management systems or bridge management systems or asset management system is giving us the ability to take the right decision in the right time. I mentioned earlier, yesterday or the day before, the right decision being delayed, sorry, right? So take the action while the damage is still minor. Okay, types of maintenance, and again, next presentation will be dedicated only to one type, which is preservation, but in our roadways, we have some of the normal routine maintenance, removal of debris. Somebody might say, okay, how is this related? This is a very simple thing. But you tell me, what do you think the non-removal of debris can do to impact long-term performance or even reduce the resilience of our road network? Anybody think of something here? Perfect. Very smart. That is the major thing. It is actually, 2 years ago, I did a project on how to optimize drainage for bridge decks. They started by bridge decks because it's very small, so they can control it faster than lengthy highways. And also the blockage of drains on bridges is even more scary because, its impact will be immediate hydroplaning. The water has, nowhere to go. So having a thicker layer of water on the bridge decks means hydroplaning, means accidents. So blockage of drainage is one major thing. So clearing the drains of road network is one important activity. The repairs of shoulders. What can this do if you ignore the shoulders? Huh? The road will? Perfect. One of the pictures for part of what happened yesterday, because there are two damages that happened yesterday, it is relevant to the shoulder, ignoring the shoulder repair. They invested so much in the highway, but ignoring the shoulder with some excessive rain, literally the road is gone. So, what year? It was like 2 years ago. Yeah, I'll show you the picture. I'll show you how the asphalt is brand new. Now, that's what I'm saying. Somebody will be under fire in North Carolina in the next few days. I'm really watching what's happening in the news because taxpayers, in America, they take it serious. It's like we're paying a lot of taxes. You're using them to create some infrastructure. And this is a major road, and it's eroded, or it collapsed. Patching of potholes. Potholes in itself is an indication of very poor preservation because you hardly see a pothole evolving immediately. The very first start is either a longitudinal crack or a transverse crack. And then it starts to develop hair cracks left and right, like a cobweb. And then not only this, it grows, so it's an alligator crack. And then not only this, you leave it for cyclic loading and fatigue, so the asphalt starts to pop. That is when the pothole shows. So a pothole indicates that you ignored hair cracks, you ignored the expansion of the hair cracks, you ignored the alligator cracks until it developed. So it has been giving you signs and warnings, and nobody is listening. So this is one bad thing. And in the US, what scares them the most is ruts comes after the potholes because of safety, especially with very fast speed or high speed. Cracks, as I said, that is the first step to the formation of potholes. So the seal of the cracks. Now this one, if ignored, as I said, it will grow into further damage. And you know, as we will see in the next presentation, sealing cracks is the first step. It's still considered under preservation because according to the FHWA definition, preservation would include any activity that does not increase the capacity. And they're very precise about this because the money, the pool of money they spend to do preservation is different than the pool of money they spend to do maintenance or repairs. So they have to define concisely what activities would fall under preservation, so that where to get the money from, and what activities fall under maintenance to also get the money from this other pool. So sealing of cracks is considered a surface treatment and a stage 1 into the routine maintenance, or let's put it better word, you know, because routine maintenance is under preservation. The term is maintenance, but because it's routinely done, it does not include any additional or increase on the capacity. So it falls under preservation. Now, other types of maintenance, renewal of roadways or road surface, chip seal. We will, if you guys can play chip seal video, that will be good. It's actually repeated on the next presentation, so if we can't do it now, we can still, okay, that's good. So watch this one. I got a couple questions yesterday about chip sealing, side questions. Is the sound
notice on their door?
Yeah.
Is this an evil conspiracy? What is chip sealing? Why does the Ada County Highway District continue to torment us?
You
with
usually
this
find
unwelcome
such
summer
a
ritual?
sign on your door before they go
Asphalt
do
is
chip
like a
seal,
protective
because
skin
it's
covering
basically
our
find a
streets.
place to park your
Without
car.
treatment, it begins to decay from the effects of sun, weather, and traffic. It loses its elasticity, becoming brittle and cracked. Chip sealing provides an armor of coating that renews the surface of the road, extending its life for an average of over 6 years. And here's the best part. Chip sealing costs 1/10 of the price compared to an asphalt overlay, and it keeps the road in good driving condition. An overlay, essentially a new layer of blacktop, is required when a road surface fails, something that will occur in about 20 years without maintenance. Every summer,
These are the
ACHD
chips,
chip seal crews
what you are
go
seeing
into
here.
one of 6
It's a
areas
1/4 to
and
3/8 of an
identify
inch
which
diameter
roads need to be
coarse
chip sealed.
aggregate.
In the spring, workers repair potholes and seal cracks. They notify neighbors and businesses in the designated areas of upcoming plans to chip seal. Property owners with large trees near the street must provide 14 feet of vertical clearance above the pavement to make room for maintenance equipment. And if trees need pruning, ACHD typically gives residents 2 months' notice to take care of it. They'll ask residents to refrain from parking on the street during the chip seal process and to drive slowly on the newly sealed surface.
If vehicles stop or start abruptly on a fresh chip seal surface, they will remove the driving surface of rock and the oil sealant underneath. It is unfortunate when this happens, as those spots cannot be repaired. Once it's done, it's done.
After repairing potholes, workers sweep the road clear of debris. Then an asphalt distributor truck shoots 1 lane at a time with hot liquid asphalt between 140 and 180 degrees Fahrenheit. Immediately after the liquid asphalt application, the chip spreader follows to embed the chips in place quickly while the asphalt is fluid. Next, rubber tire rollers make 2 to 4 passes over the rock chips to set the rock into the oil. After completion of the first lane, they proceed to the second lane with the same treatment. Within a week of this application, a sweeper comes through to clear the area of excess rock and dust. Later, a thin fog coat of oil seals the new surface in place, reducing dust and securing the rocks. This adds life to the chip-sealed surface. Motorists can drive on a newly chip-sealed surface within minutes and on a newly fog-sealed surface within a half hour. Within weeks of the fog coat, crews come through to paint stripes on streets and crosswalks, creating the look and feel of a brand new roadway at a fraction of the cost. The chip seal process is continually reviewed, then revised and updated according to input from the public and as innovations and new products become available.
We use a latex modified oil which sets up within minutes, allowing us to open the road very quickly. Our program has developed a lot over the years. We use a 3/8" chip size on the main roadways as it provides a longer wearing surface for traffic. But we use a 1/4" size on residential streets so it's smoother for skateboards and bicycles. The chip seal process has a lot of moving parts. It's a constant process of watching what we're doing out there and making adjustments as needed.
As we strive to make improvements to the chip seal process, ACHD welcomes your input and feedback. We know the drawbacks. Chip sealing is messy and inconvenient. Chip-sealed streets are bumpy for skaters and scooters. We have switched to smaller chips to help prevent windshield damage and to make a better surface for cyclists. The alternatives to chip sealing? Let roads deteriorate into cracks and potholes over 20 years, then go through the costly process of new asphalt overlays. No other road treatment offers the tremendous economical savings and minimal inconvenience of chip sealing. Although we maintain nearly 5,000 lane miles of roadway throughout Ada County, ACHD's primary commitment involves much more. A commitment to safety, to high-quality results, a commitment to service, and to you, the customer. Chip sealing saves you money and produces a great result. We understand if you don't like it at the time of placement, but we do think you'll like spending less tax dollars to keep your roads in better shape.
It is important to us at ACHD that the public realizes the benefits that chip sealing provides for our streets, and to please be patient with us as we come through your neighborhood. A little understanding goes a long way, and we'll get out of your way as soon as possible.
We thank you for your patience and cooperation.
Okay, so what is the target of this whole procedure? Think about what they have done. Did you follow the exact process here? What was done? So if you tell me this is reactive maintenance, no, it is a preservation. Why is this considered a preservation? Well, first of all, it
happens every summer. A group of Ada County residents.
It never increase the original design capacity of the highways. So what happens here, with time, you start to see a little raveling, it expands, you might see a little bit of cracks, so your PCI or PCR, however you say it, pavement condition index or pavement condition rating starts to drop. The more the deterioration, the higher the drop. Until a specific point after which it's no longer preservation, it has to be a maintenance, and if delayed more, it will be a replacement. So in the very early levels of drop, where you are still beyond 70 or 75%, between 75 and 100, you have some signs of deterioration like raveling or minor cracks. If every once in a while you find a bigger crack or a pothole, you have to treat it independently. As you have seen, they said before chip sealing, you have to have crack sealing or patching of potholes. Because this chip seal, the whole layers, the added is in the neighborhood of 1 inch. So if you have any extensive cracks or deep cracks or wide cracks or potholes, this is not going to be enough to fix them. So you fix these cracks or seal the cracks and patch the potholes, then you start the process of chip sealing. Now, how the process is done, basically they have a spray, an initial spray of what they call a fog seal, not chip seal. Fog seal is an emulsion, or basically water mixed with binder and emulsifying agent. Very light. It's only done with one truck with a sprayer. It basically smooths the surface. Of course, you clean the surface first and you patch the potholes and you seal the cracks. Then you make a fog seal layer. Then after this, you bring the chips. Chips is like, coarse aggregate but small size. And it looks like the corn flakes. It's chipped. Now, what size of this? They started, or usually if you are in a major highway, they do a 3/8 of an inch. If you are on a residential area, they do a 1/4 inch or 2/8 of an inch. The reason is the thicker the one, usually skateboarders, as they mentioned, or people walking with canes or on wheelchairs get stumble on it. So they always complain. Then after you spray this layer of chips on top of the hot fog seal, you have this rubber rollers going back and forth 4 times to compress the chips into the hot fog seal. A week later, they come with the brushes. They clear all the loose ones to avoid any future accidents. Then they come again with a layer of fog seal on top, like to sandwich this, this chip seal. So what will this do, or how could this increase the resilience of your highways? Can anybody tell me? Whether it's a low volume road or a major road. Any ideas? Well, lifespan is increased, life cycle cost is decreased. However, this is more into strength and durability. But think about resilience. Resilience is when some additional stressors happen. Think about if you have rain on a highway that has got a lot of cracks. The water would dissipate below the wearing surface. Now, depending on the weather, if you have, if you live in a country like the US, if this water is there and then the weather cools off, frost heave, the road is gone. But if you prevent the water from going below, then the road will be resilient. Once the rain happens, you are still capable of course, up to a certain level. Even, if you have a huge rain and you have chip seal, is not going to do. There is a certain level of enhancement of resilience, but after which chip seal by itself is not going to be enough. Something else. That's definitely, that is one other thing, the rejuvenation of your project. Also think about rainwater, not only remember from yesterday, the roughness of the surface is a factor that help or be against you when it comes to drainage. Chip seal in itself, it's not so, smooth. However, it's much better for your rain to dissipate to the drains through a chip sealed surface rather than going in a surface that is full of cracks and potholes. So you have a much higher efficiency in your drainage. These two parameters, the better drainage and preventing the water from going below the road, the top surface, are extremely important when you talk about resilience or how you would be capable of resisting or standing against unforeseen environmental things, predominantly, as I said, rain. Can we have the presentation back? Oops. No. Now, full depth reclamation, we talked about this one before and how it is made. Here is another quick video. I hope we can play it. But this one, it's basically trying to reduce any impacts because of poorer subgrade.
Full depth reclamation, or FDR, is an asphalt recycling process where the full flexible pavement section and a portion of the underlying materials are uniformly pulverized in place, then stabilized with Portland cement. The result is a cement-stabilized base course, using all existing materials to create a much stronger, stiffer, and more durable section for the new pavement or surface layer. FDR is a cost-effective, fast, and more environmentally friendly alternative to total reconstruction. FDR is how Mount Carmel Stabilization Group began in 1949, and today we do over 100 miles per year. This roadway is exhibiting common base failure, with alligator cracking, full-depth patches, edge failures, etc. The city of Louisville, Kentucky elected to use full-depth reclamation to rebuild this road because it was superior to patching and far more cost-effective than total reconstruction. This roadway is a great example of FDR because no materials left the roadway during construction. The first step in the FDR process is to pulverize the existing asphalt, base, and a portion of the subgrade in place to create a homogeneous material. On this project, the treatment depth was 8 inches. Depending on the project, treatment depths from 6 inches to 16 inches are common. During this phase, the mixer is pulverizing the full depth of treatment. The gradation of the pulverized material is important during this phase. Typical specifications are 100% less than 2 inches. It is during the pulverization phase that any widening and reshaping takes place. This is important to have completed prior to the beginning of stabilization. Widening is easily accomplished during pulverization if the existing roadway platform includes a shoulder on either or both sides of the road. After pulverizing, the material is graded and sealed prior to stabilization. Phase 2, stabilization with cement begins. The first step in stabilization is the application of cement on the grade. Cement is spread at the prescribed application rate, taking into account the new composite soil weight. On this project, the cement application rate was 6%, which is a common and effective application rate for FDR with cement. The cement is mixed with a composite base to the full depth of treatment, with water being added through the mixing drum to hydrate the cement and bring the mixture to optimum moisture content. Immediately behind the mixing process, the process continues with compaction and initial grading. Compaction is accomplished with a vibratory pad foot roller, followed by finish grading and sealing with a steel wheel roller to provide the finished stabilized base surface. At this point, the roadway is completely open to light vehicular traffic. Heavy load should remain off the road for 5 to 7 days to allow the cement stabilized layer to cure. It is also common to shoot a bituminous tack coat on the roadway to seal the surface prior to paving. You are viewing the finished product with a 2-inch asphalt pavement directly over the cement-stabilized FDR layer. The City of Louisville chose to leave a 1-foot stabilized shoulder for edge control for the new pavement. The entire FDR process on this 1-mile roadway took only 2 days. Add 1 day of paving, and to reconstruct this road with FDR took a total of only 3 days. Utilizing all existing materials, FDR is the most economical process available for recycling failing pavements today.
Okay, so before I proceed after the FDR, I just wanted to mention one thing on chip seals, the previous topic. is the process you have seen of chip sealing is of an existing roadway. Typically, these could be collectors, arterials, even expressways or interstates, as big as interstates. However, low volume roads have a lion's share of enhancing the resilience by chip seals. Anybody can think of how that is done? By definition, what's low volume road in Nigeria? Do you have a specific national definition? Less than? Okay. LVR, yes. But is there a cutoff number? I heard 300 here. Yeah, I'm not aware of a national standard in the US. Most of the states, though, where I did business with, or the DOTs I worked with, they adopt a number 1,000. They tell you lesser than 1,000 vehicle a day, that is considered a low volume road regardless to its geographic location. So as I mentioned in one of my earlier presentations, they have a problem working on this highway because the two major sources of funding for highway from within the state are not available. Whether the gas tax, nobody's driving or very little driving, so there is no gas tax generated from selling. Gas is petrol, right? Also, there is no toll station. You will never put a toll station on a low volume road. So they are very low down in the priority, whether on new construction or in maintenance. So if you remember from yesterday's presentation, what is the length of the highway network in the whole United? For almost 3.97 million miles and more than 8 million lane miles. You know the difference, lane mile from regular mile, right? Out of this, 64% are paved, whether flexible or rigid. Now, what about the other 36%? And 36% of this is huge. It's close to 1.5 million miles. So these are mostly low volume roads in very rural communities. So the government is not paving them, or they use chip seal only. It's not a full pavement. You have the dust road or the dirt road, you can either leave it as is. But then when there are complaints, like if there are, a lot of these communities, they are on rural area in the woods, so there are some trucks cutting trees, going back, so there is a huge amount of dust evolving on air. So in order to oppress this dust, they do a layer of chip seal right on top. So you don't have a subbase or a base. You just end up having a compacted subgrade and then a layer of chip seal on top, and that represents 100% of the section, and that's only 1 inch. While a regular road, you have like 20 inch of subbase and base, and then 4 to 6 inch. So they replace 24 or 26 inch of pavement or pavement section with just less than 1.5 inch of a chip seal, right? So they try to oppress dust, but in a way it's better than nothing, because once you have rain, this chip seal, you can view it as what they did in FDR when they do cement stabilization for the base layer. The chip seal tries to keep the soil intact. So if you have little or mild rain, you don't have an immediate washing or erosion. So this is one of the benefits of chip seal, or how it increases resilience. So in major highways, it's more by resisting water or rain or stopping the frost heave. But on the low volume roads, it lowers the chances of erosion. Now, coming to FDR, is it being done here in Nigeria the way it is? How common? Okay. Basically, it is, it's borderline between preservation and new construction, because basically you are still maintaining the capacity, but you are, there is a huge debate about this one, whether it can fall under some sort of severe maintenance, or it is considered, I personally see it as maintenance, not preservation, but you know, either way, that's a political debate to where to get the funding from. But we can see how that will enhance the capacity of our roadway network. Now to some emergency. These are real pictures that we see, and it's not uncommon. I'll show you the pictures my son sent to me midnight yesterday towards the end. So it's very real, and it is less than an hour drive from my house. But landslides are very common in the United States. Lots of our roadway network, whether you talk about low volume roads down on the woods or up on the woods, or even the major interstates. Like, you know, I used to work until 2017 in the state of Arkansas. Then I moved my whole house to the state of North Carolina. So you have to, it was a 16-hour drive. I was having a U-Haul truck. It's a big truck with all my furniture in and towing my son's car and driving. So you drive slowly because I was driving a huge, heavy thing, right, for 16 hours. So I had a chance to stop, rest, see the topography around me. You know, once I hit, you know, between the state of Arkansas and the state of North Carolina, you have the state of Tennessee. And if you're familiar with the United States, one of the national parks there, it's called, you know, the Smoky Mountain or something like that, where you have the mountain and then the clouds around them looks like a smoke. So they call it the Smoky Mountain. You cut across these. The highway you are cutting across is literally embedded within the mountains, right? And this is a huge distance. You know, out of a 16-hour drive, I passed for 8 hours. So I saw every single type of soil support. You know, my son was mad at me. He was like, hey, I slowed down. What are you doing, Dad? Well, I'm going to park and take a picture. It's like, you know, we're driving 16 hours and I told him, well, nowhere else on earth I'll see, you know, geotextiles, geofabrics, soil nailing, welded wire reinforcement, shotcrete with fibers. You saw every single aspect done by the government to stop the land slides because it is dangerous. Now, the danger is quadrupled, probably, when you talk about LVRs. Why? Well, at some point, it's a huge network. Think about close to 1.5 million miles. Very rough topography. Extremely low quality roadway. Either it's pure dust or compacted dust with some chip seal. So you can imagine what's going to happen when you have any sort of little bit high rain. There is no proper slope, no proper section for flexible or rigid pavement. It's not smooth. Soil is not well compacted, you name it. Maintenance is very limited, if existent. So geotechnical studies are not available. So in low volume road, it's very prone or it's susceptible, and this is very common that you see. And the moment that this thing happened, normally these communities have only one road leading to them. So you get a 911 call and they're asking for helicopters. And the DOT has to provide helicopters to evacuate them. Otherwise they will die, no food, no nothing. So how to protect? These are lists. And you know, the more you stabilize, the more you're enhancing the resilience. Because basically, no stabilization, then good luck. Think about the damage. I mean, even with stabilization, you would come through some damage. But the damage will be in limited spots, and it will be minor in the magnitude. So you can fix in a day what you will need to fix in several weeks if you have no soil stabilization. That is exactly in the core of definition of resilience. It's precautionary steps you take, or adaptive steps, adaptation procedure that you take in the good time without when there is no problems, just to prevent or even reduce the magnitude of your problem so you can evolve from the disaster. So how many of these techniques are followed or done here in Nigeria? Nailing, grouting, use of mesh, rock bolting, use of retaining walls. Retaining walls? What's that? Okay. How about the soil nailing? Is it done? Rock bolting. Any rock bolting? No, gabions is different than rock bolting. No, I know gabion is like a retaining wall, but it's inside a mesh with big rocks. That's a gabions. Gabions are very common in the Arab world, like in Erbil, the highway taking you from Iran to Iraq. I drove through this highway. Gabions are very common beside the mountains. Erbil is like high topography, so they have a lot of mountains. So even interstates or intra-countries between Iraq and Iran, you know, they have gabions long way. But rock bolting, it's more, well, they use it in the US because it's a technique done in tunneling. When you use TBM, the tunnel boring machine, and cut across a rocky area, instead of supporting the whole thing, you know, the theory there, if you have major rocks, they can hold themselves by themselves. But if you cut through rocks and then there is fragmentation, that's where you apply the bolting, which is very close to the soil nailing, but it is done in rocky soils. So that basically they use or take advantage of what we call, I mean, I'm heading now into structures, but have you heard about the shear friction concept? Shear friction. You know what shear friction is? Any structure engineers here? I heard a yes, but you know, from the light. Huh? Yeah, but shear friction, what is shear friction? Okay. Let's say I gave you 10 books, just books, and I asked you, I want you to hold them or prevent them from stopping. How would you hold them? You'll make your hand like this, right? So you're having the weight and then action, reaction. Now, if I told you I want you to hold the books from the side, there is a way. You can't do exactly. You cannot use one hand. You have to compress. Now you are compressing like this. You are providing horizontal force. But this horizontal force are preventing the books from falling down. That is through what we call shear friction. Basically, you apply a force. This force multiplies the coefficient of friction between the books, convert itself to a vertical direction. You know, where shear friction is used, you know the corbels, when you have a corbel extending out of a wall, and then you have a crane. The crane is pulling the corbel down. Now, you will not reinforce it horizontally. You are reinforcing the corbel laterally into the wall or into the column. Okay, so definitely the interaction between, or the section between the corbel, or corbel is like a cantilever, right? A short cantilever. This intersection is cracked, but why it is not falling? Because of the horizontal rebars. But how come horizontal rebars are resisting vertical? Basically, the tensile strength, you multiply it by the coefficient of friction of the broken concrete, gives you a vertical force. That is what we call the shear friction. That is what rock bolting is doing. You know, let's say you have a tunnel. The top of the tunnel is going to fall. When you have a rock bolt, it's compressing rocks together. It's not doing it vertically. It could be doing it horizontally. Let's say a horizontal wall. You're rock bolting to the side. But this side force multiplies the coefficient of friction between fragmented rocks is the shear friction force that convert from a horizontal force by the rebar into a vertical reaction. So this exact concept, which is used in tunnel design, is what could be used to prevent the failure because of any erosion or any rain, and that enhances the resilience. Other thing here is drainage improvement or elevating the roads, and we will, oops. Yeah, so what about this? See the rock bolting, soil nailing, and grouting. Or you can have multiple techniques together. You can see the grouting on the top left. You can see the soil nailing down. You can see the rock bolting up. And you can do rock bolting with meshes. You can do rock bolt with a mesh and a shotcrete. And this is done when, you know, the TBM results into excessive rock cracks. So bolting only may not be enough. There might be smaller sizes, you know, because a rock bolt, you cannot do a rock bolt every foot. It's very expensive. So you do it, they are spaced apart on XY, it's like a grid. Between them, if the rocks are in good shape, probably bolting is enough. But most of the cases to secure, you end up with a rock bolt with something else. So improvement of drainage. And we will, I'll talk on best management practices about how to improve. So one thing to enhance the resilience in a low volume road. Do you see what I mean by this? Try always to follow the topography when you build your highway, especially in such areas. What I mean by this? Well, there is one economic reason. If you do a highway, you want to minimize the amount of cut and fill. So if you follow the contour lines, you are basically going into the same level, right? But if you cut across in contour line, you know contour lines, right? It separates different slope, different levels. So if you cut across or cut perpendicular or at even an angle, the more you cut into an angle onto multiple contour lines, well, you are shooting yourself in the foot immediately. Why? First of all, you will increase the amount of cut and fill. That is one thing. You will increase labor cost, need to equipment, time of construction. And also, the drainage is not going to be appropriate. Your highway could have extensive slopes, that's for sure, but you are prone to erosion. However, the more you go, as you see into the top left, kind of parallel, that would help you when you do drainage side-wise. And that is the best when it comes to construction practice for minimization. Now, providing adequate surface drainage. We all know that the drainage, if you remember from yesterday when I asked about manning or hydraulic, you have 3 parameters that control the speed of the flow. Do you remember them? Roughness coefficient, that's one thing. The higher the smoothness of the road, the lower the manning value, the faster the flow would go. The slope, of course, the higher the slope, the faster the flow. And then what we call the hydraulic radius, it's not important now because the slope and the roughness are the most important parameters. Now, generally, roughness is high in low volume roads, right? So speed tends to be reduced. So we have to take care of the slope at least to give an opportunity for proper drainage. You can see if you have a crown road, typically it's a 3 to 5%. Less than 3% will give you a problem because of lack of drainage. More than 5%, you would expect very high speeds and erosion. Or you can do outslope like this in a 3+%, or you can do inward, but when you do inward drain, you have to watch for the fortification or armoring the ditch. Otherwise, the drain itself will result into the road collapse. So this is what you can do. That's inward or in-slope ditch draining. So this is extremely important. So if you do proper sloping with no fortification, good luck. Few years, this water will be your enemy. This is out slope. You have to do also fortification. Most of the time, if you have enough to 1 to 2 slope, you end up with normal plantation. If you get closer to 1 to 1, then here you have to do something, whether geotextiles or geogrids or welded reinforcement, or if you go way more vertical than 45 degrees, then possibly you have to end up with gabions or retaining walls. Avoid steep slopes. Steep slopes here over 60. You have to do this benching. So you can stop or reduce the chances of washing off your highway. These are all for enhancement of resilience. Here you can see when you do cut fill on the highway, the old versus the new road, you have to watch for the slopes as in the picture. You know, again here, you can see different slopes, 1 to 1, 1 to 1.5. So you have to end up with this right slope when you do cut fill, otherwise you are shooting yourself again. Now, that full slope depth, you can see here how they do multiple layers. Technically, if you don't do any fortification, they are doing 50 to 60 centimeters, and then they compact it very well. Of course, it depends on the slope. Now, if you have higher slope, only compaction is not going to work, so geotextiles and geofabrics are used. Unfortunately, we have no code for designing, so every company, based on the product they provide and based on empirical trial and error testing, they tell you how often you put your geogrid, but most of the companies I have seen, it's 2 to 3 feet. Some companies, they tell you 6 feet to have a wide geotech, 6 feet every 6 feet, but on the middle, every 2 feet, you put a shorter geogrid towards the slope. So if you look on a profile, you find a very wide one, then 2 short ones, and then another wide one spaced apart at 6 feet. The whole intent of this, it provides some sort, it's like confinement. It's like, you know, when you do a compression test on a concrete and it fails at 4,000 psi, if you make confinement on the same concrete and compress, how far? Would it fail at 4,000? Of course, much higher. Because the confinement, it's like the same idea when the weightlifter wears a belt. He makes a lateral confinement so he can lift more. That is the same exact thing where you apply geotextiles. Yes, sir? That grassing?
Yes. So is it not considered as a way of improving?
You mean applying greenery? Yeah, that's what I just mentioned here. I mentioned it here. Yeah, outslope. Yeah. Yeah, actually it is. Actually, there are, especially, in North Carolina where I am, on the areas close to Atlantic, because they apply even special plants like mangroves, per se, because of how deep the roots can go. So they consider that at like a sort of a natural soil nailing. You know, so no, it's very common using greenery to support slopes. Now, this is a bit of a case study here, and I'm getting close to the end. So look at this. This is a highway. You have two problems. One, you have a cut failure, and the other one, you have a fill failure. Again, you have some cuts and some fills. So you might end up with, see these? Two. So these are 2 weak spots. So what can you do? Well, you have first to reduce the slope, and then at the bottom, you have to do some armoring. It is like gabions, but you don't have the welded mesh here. It is just sort of like a riprap, per se, at the bottom. This is one option. Now for the fill failure, typically the way you do is the enhancement of the soil with, either you do a lower slope and you do compaction on very closely related layers, or again, you end up with geofabrics or geotextiles, or you can do plantation or you can do soil nailing, but again, I'm talking about the easiest or cheapest to avoid the use of high technicality. So these are some pictures. Plus you have to end up doing some fortification at the bottom or to armor the bottom of the slope. Regardless if it's a failure because of a cut or because of being a fill. So you can see here, so they're re-sloping plus making some support at the bottom. Again, standard retaining walls, whether bulkhead walls or cantilever walls or counterfort walls, all type, are also being used, but they try to minimize their use. I'm not sure how much a retaining wall here costs, but in America, per foot area, like you calculate length by depth, and then that gives you the square footage. It goes up to sometimes $60 and $70 per square foot. Square foot is 30 centimeter by 30 centimeters, so it's extremely expensive. I'm doing a project for our DOT where we're doing a short wall, 220 feet, about 60 meters, and about 6 meter high. And the initial studies, including all the earthwork, back and fill, grading, plantation, we're talking about $1.1 million. It is really expensive, so they try to avoid using it. Now, hydrology, this is the equation to follow. So the CIA, not the CIA we're all afraid of, divided this, and then here this is, of course, that is area of flow multiply, run coefficient multiply the intensity. Okay? So I'm showing here, hydrology for low volume roads, the I for different ones. Here there is the Manning, it's another way, that's to calculate the velocity. So 1 over n multiply r to the 2/3 multiply s power half, so it shows you that S is a major factor, which we said 3 to 5 inch if you have a crown slope, 3.5 inch for inner outward slopes. That's a decent lateral slope. And then N is the roughness coefficient. R is the hydraulic radius, which is the area of the flow over the parameter. Now, natural stream crossing is a big problem, and that's what made yesterday's failure in North Carolina. So you can either cross, any of these ways. Now, the bottom two, which we consider culverts, by definition in the U.S., if you have lesser than 20 feet span, it's called a culvert, even if it's built as a bridge, right? So the top one, top left, it's considered bridge only if it exceeds 20 feet or 6 meters. If it is less, they consider it a culvert like the ones down, as if it's a pipe, even if it's a bridge. Now, natural stream crossing, you have to try to make a way out for your water, like if the cross-section is not enough. One rule of thumb is you better have the stream crossing or the highway crossing the stream perpendicular, just to avoid erosion effect. So if you have an angle at the intersection, not a 90 degrees, you have to watch for possible erosion that will happen. Also, you have to give an alternative way. You can see there is an armored way here. If the water is passing from below, you have to consider making a pass. So if your culvert is plugged or clogged or it's not enough, the water can you find this other easy way, which you basically provide for the extra water to pass instead of washing out your soil. Whoops. Yeah, so these are not recommended where you have that route of excess water parallel to the highway, because if you get flooded, the water will wash your highway. Do's and don'ts: if you are providing drainage across an embankment section, make sure that the spill of the drain is below the very bottom of your embankment, because the water, once it gets outside, there is a bit of erosion that is going to happen. So you have to extend your pipe or the drainage pipe below the embankment, below the lowest point, to avoid the erosion of the highway embankment. Same, avoid having this thing. Do you know what the top right one is called? It's similar to what we call hydraulic jump in hydraulics. You'd have very high energy if you have the culvert dropping the water from a height like this. So it will end up with erosion at the bottom of the embankment. That would extremely reduce the resilience of your roadway. Even with normal rainfall, with time, you're done. Now, this is Irish crossing. They use it in the Arab world, some locations in the US, where they have their deck really low, in low volume roads. They don't want to invest in having elevated roads or bridges. So they make the crossing like this, and they know that there are maybe a couple times during the year the water would pass on top. But then at this point, it's not only a matter of resilience, it's a matter of threatening lives. You have to block, to make signage to stop traffic, because some people, especially those with high trucks or SUVs or 4x4 cars, they think that that height of water, well, we can walk, but this is running water, this is not stagnant. We just had a case where in North Carolina, the guy found like 4 inches of water. He said, oh, my car is high. And he went through, the water drifted him, he died. He basically fell into the water and he lost his life. So it's not only, this is not only resilience, this is a safety. Now, these are the last 2 slides on my presentation, and these I got from my son yesterday. He's the one driving the car. You can see how beautiful the nature is. The roadway has no cracks, no ruts. It's newly built, very prominent neighborhood. You can see up front to the left what's going on the right-hand side picture. The very front to the right. What do you see here? This is? I can't. Carriage? Yeah. Exactly. Because what happened, they didn't do proper sloping or proper soil support. So it was washed out. So basically, the subgrade is gone. So that is just a picture I got midnight, and my son took it at like 2 p.m. or something yesterday in I-40. And look at that. They probably invested a lot protecting from landslides, whether through plantation or soil nailing or whatever. But then the embankment itself was not well protected. So you can see basically the side of the road is washed into the water, right? So think about the losses due to reconstruction, and more than that, think about the losses due to stopping people from traffic. This is the one, everybody going to the capital of the state, going to the airport, going, life would stop. See this? What do you think this one happened because of? Huh? This is a culvert, and it is a corrugated sheet culvert. Corrugated metal sheet. In the US, there are the traditional way they do rectangular cross sections. Now in order to get the cost down, they decided to shift to corrugated metal sheets. If you see them, it's standard size sheets, it's shipped, and then it's like being drilled together. In less than 48 hours, the whole bridge is made, and they do the subgrade, and then subbase, and then base, and then the wearing surface. So here what happened, remember the last couple slides I mentioned about proper design for drainage and giving the water an alternative way to spill if you get an overflood. Basically what happened, you can see the asphalt is fairly new. You can see the thickness of the asphalt layer. You can see the subbase there. The contractor did a good job on the surface. That's what I can see it. But he didn't do a good job when it comes to the hydraulics. And I assume the designer didn't do a mistake, maybe because I do a lot of design, I'm biased, but knowing how the people are smart and how the specs are followed, I think it was properly designed, but there was no other alternative made to get the water out. Then when sudden rain came, corrugated sheet burst, and then it fell because they are tied to each other. They got separated, they washed, and then the subgrade fell, and then you can see there is no preservation to be done, there is no maintenance to be done, it's a full repair. So before this event, you can grade this highway as an A or as an B. But because of low resilience, once it was hit, it shifted from A to F. That is what we can call resilience. It didn't go A, B, C, D, F, no, A to F. So that's why the measure of resilience is extremely important. Don't ever be deceived with the current strength, because you might have a defect like improper slope protection or improper drainage or that makes you prone to massive failure or massive drop. So instead of doing a 1 or 2 day preservation or 3-4 days of maintenance, you have to do a whole reconstruction. So this is extremely good condition highway with extremely poor resilience. Yes, sir. I see your point. I see your point. Somehow they're connected, because it could be like if you design the road and you didn't do a proper design for side slopes and you had failure. This is poor resilience, but it's poor resilience because of poor design. You see what I mean here? You didn't pick the right alternative. My resilience is somehow attached with the design. Like if you pick on the topography your highway with a lot of cut and fill issues across slopes, that is a poor design. Even if you design it poor and did a good quality contracting work, then it's not still resilient because of the poor design. Or if you do a good design and the contractor had a rough surface, that will be a poor resilience because of poor drainage, because of poor contracting. But there has to be somebody responsible for poor resilience, whether it's a problem in the design, problem in the execution. You know, a poor resilience, anything poor, any mistake, somebody has to be responsible, right? Whether it's a designer or the contractor. So I see your point. But here, I don't know, I'm biased to designers because I've seen how this thing go through reviews and, you know, so basically, I don't know. I mean, it's probably, the spill was not like, look, inadequate capacity, that makes it poor design. But if the capacity was okay with a chances for an alternative spill, and this one is not taken care of, then it's a poor execution. So again, it depends. That just happened yesterday. So I received this, like I made this like 2 a.m. when my son sent it to me midnight. So, I mean, there is a lot of investigation going on. Maybe next course, inshallah, I'll be able to bring the outcome of the investigation and what has happened. So that concludes the presentation. I'm not sure if I went over. Yeah, we're here for questions.
Check.
I mean, I see your point, yes, you probably raised your highway. It could happen, yes. But it's not a huge raise because basically you do huge compaction. Also, yeah, I mean, you will end up with a raise, but it's not a huge raise.
No, for the base, 250 for the base. We are at 260.
Yeah, but also the FDR, they consider the compacted layer after including the mixing is your new subbase and base. So they only add a wearing surface or a layer of chip seal on top. So yes, you would increase the height, but you're talking about 1 to 2 inches. I mean, which Yes, sir.
Yeah, thank you for the presentation. I
My
have
pleasure.
just only 2 questions. In the lecture delivered, it was centered.
Can you raise a little bit or get the mic
Yeah,
closer?
in the lecture delivered, it was centered majorly on climatic resilience. But resilience safety is part of what should be considered. And on the ship seal,
Uh-huh.
I don't know whether you can tell us the size of the chips. Then
No, I said it.
yeah, I'm going somewhere. Then the frictional coefficient for skid resistance compared to either the surface stress. We know that of asphalt is 0.7 to 0.8. Because when we're talking of resilience, safety should be considered. Then the second question is on slope. I noticed that very many a times we work on what we say are maybe slope 1 to 3, slope 1 to 4, and thereabouts. But in a situation where, because I was in the project that we filled about 70 meters, and I expected that we should be involving the geotechnics experts to look into slope stability.
Sure.
And that would tell us that all the methods that probably you brought about, it will be a guide. So I think that thing as well should probably be explained a little. Thank you.
Okay, so you asked about multiple points. The first one, the size of the chips, I mentioned it. It's either 1/4 inch or 3/8 of an inch. Usually you use the larger on interstates or larger highways. Use the smaller on residential areas because of skateboarding and wheelchairs and people walking with a cane. This is one thing. Number 2, skid resistance. One thing I have to mention, and I think they mentioned it on the video clearly stated that chip seal, you usually get complaints because of the surface roughness. So basically this complaint has to be well taken care of more in the residential area rather than in interstates. Because residential areas you have people walking, biking, so the impact is high. Skid resistance, it go up, so there is no complaint of resisting the skidding. Skidding, it's better. When you have chip seal, your car has higher tendency to stop. It's the problem with the smoothness and the skateboard users. So that is why they stated about after they have the first seal layer, then the chips, and then they compact the chips, they clean the chips, they have to do a fog seal layer at the top. So the whole thickness is about 1.25 inches, maybe 1.5 inches. The top layer would cut down the roughness and make it more convenient for people walking on their feet. So that takes care of the complaints about the roughness. No skid resistance problem, it is roughness problem. What else do you ask about other than these? No, the involvement of a geotechnical? You said whether you need to involve
for the slope stability. Like most of these things, probably there have been research into that. But you know, when you're constructing, the type of soil varies, as in the property of the soil of the laterite usually varies. And I feel that in knowing the type of slope protection to use, we should involve the geotechnical experts.
For sure. One of the designing team is a geotech engineer. You have to do geotechnical analysis before you do anything. The geotechnical analysis, the first thing it tells you what type of soil you have. There is 3 main types, and every type has got a maximum permissible slope, whether 1:1 or 1:1.5 or 1:2. That is decided by a geotech guy. Also the type of activity to take, whether you do grouting or soil nailing or rock bolting if it is more towards the rocky side, or plantation, or using welded wire fabric. These are all, or even geotextiles. It is, as I mentioned, you design it according to the specs of the company with the aid of a geotechnical person. So yeah, it's a teamwork. You don't have only a materials or an asphalt guy. You have to have a hydraulics guy for the drainage. You have to have a geotechnical guy for soil or ground improvement techniques. And then you have to have the structures guy if you have bridges or anything like this, and then the asphalt or the materials or the highway guys for the soil or the embankment and the wearing surface design. Any other questions?
I have two questions.
Yes.
The first one is on the FDR. What criteria do you use to decide if a pavement is suitable for FDR or full reconstruction?
What criteria used to design what?
What criteria do you use to decide if a pavement is suitable for FDR or total reconstruction?
It's mostly, well, there are a couple criterias. I think it was the vice president who was sitting yesterday. He said, or someone from the honorable people here mentioned about financial side. You or director? Yeah. So one thing is how much each alternative would cost. And remember yesterday about the life cycle cost? Now with the availability of AI and previous data, you can decide while you are building the highway, if you design it using asphalt, then these are the scenarios for deterioration, then these will be the scenarios for preservation. Or if you do it with rigid pavement, whether Portland cement or RCC, then these are the possible deterioration and these are the possible preservation or maintenance. And then based on these scenarios, and are you willing to spend the money now or are you willing to spend the money later, and how much money? Like you can fix the road by mill and fill. You can fix the road by FDR. You can fix the road by ultra-thin bonded layer. Which one would work the best? Basically, what is like if it is a bottom-up rotting, then you do mill and fill, good luck. You spent a lot of money, you fixed the problem, in a couple months it would come again. Maybe if the problem went down all the way, then FDR or full replacement are the best options. Are you willing to do full replacement? Do you have the money for full replacement? Or should you do FDR as a better option to save some money, even if it may not be 100% as strong as a full replacement? So money talks.
Thank you. The second one is what is the expected service life using a chip seal?
Chip seal, okay, we will talk about this in the next videos, but there are three types of seals. Fog seal, which is emulsion, asphalt emulsion, which is basically binder water and emulsifying agent. This is the weakest type. You usually do it in side roads, and that gives you 2 to 3 years. Slurry seals, which is fog seal plus sand, again, 2 to 3 years, but on higher capacity roads, or could be 4 years in a side road. Chip seal, it's a range. It starts from 5 to maybe up to 8 years. They claim it is up to 8 years. I've seen 5, 6, maybe 7 if you are lucky, but depends on the type of stressors are available. But to be on the safe side, consider it 6 to 7 years, more or less, give and take. Several, oh yeah. Anything is several years. I mean, there is no way you will do a preservation or replacement and you come back next month but yeah, so chip seal, they say 5 to 8. I personally, when I work on anything like this, I'm thinking to be on the safe side, I do consider 6 years per se, which is not bad. Other questions? Yes, sir.
You distinguish between resilience and adaptability and durability. What would you say is the function between, or the relation between the three? Or if there are any more factors that
function between which and which? Between
resilience, and adaptability, durability, and then if any other available factors.
What do you mean by function?
The relation.
No, I mean these are, okay, terminology or jargon-wise. When you talk about strength, it is an immediate measure of the capacity. Like when you say load rating of a roadway or a highway or a bridge, it means its maximum capacity, right? Which is how it can take ultimate shear, ultimate flexure, ultimate torsion, ultimate compression. These are the measures of strength, right? So let's say you're talking about steel bar, what you would do for measuring strength, yield, tensile. If you do for concrete, hardened concrete, will be compression, 28 days. So these are immediate strength. Comes durability. How would this strength be after several years of being used under normal conditions, right? That is the durability. Will your concrete lose its strength because of alkali silica, alkali carbonate, spalling of concrete, hair cracks, you name it? Or will it be able to withstand? So durability is long-term, consider it long-term strength, not immediate strength, right? Now comes resilience. When you expose it to what's beyond its normal capacity, or what is not taken care in, would you, like resilience of a roadway, you think about this. If you expose it to flash flood, and then damage is induced, how large is the damage? The larger the damage, the lower the resilience. So it's a measure of the impact of events. Okay, high resilience means low damage. Low resilience means high damage, more expenditure, more time to fix. What was the last one?
How different is it from adaptability?
No, adaptability is the measures you do to enhance resilience. They're not, you cannot compare. Adaptability, it's like, okay, when you do spillway, like there is a stream crossing highway, and then you do a spillway. This is an adaptability measure. So when the stream, the capacity of the culvert is exceeded, instead of hitting the roadway and eroding it, it goes through the spillway. This is an adaptability. If you change the slope to make it milder, to resist landslides, this is adaptability. So adaptability is a measure you take. It's like preservation of highways. Adaptability is a measure you take to improve resilience on the long term. You see? So adaptability is your action. Resilience is how good or how poor the reaction of the highway. So they're two different. Strength is immediate capacity. Durability is long-term capacity. So these are not, I mean, they are correlated, but you cannot say what's the function between them. I can tell you normally higher resistance normally means higher durability. Is it 100% correct? No, depends on, but higher or better adaptability means better resilience. This answers your question? Okay.
Wow.
Any more questions? He's here. He can help.
No questions.
Are you here to help?
Oh, yeah.
Please. I get the hard time, I get the questions, and he get the good news to you by saying lunch is... No, not lunch. Coffee is served?
I'm here to help you get a clap offering.
Okay.
Yes, can we give him a clap offering?
I will buy it.
Now, you can see how all of these are making sense. So there is a lot that is put into designing the road. And if you can check from all the classes we've been having, you will see that sometimes it's either we are not doing things properly, or we are not spending the right amount of money, or maybe the money that is even allocated for these projects are not enough. And you see a lot of equipment, a lot of energy, a lot of checks, and even the banks. Now, when these projects come, you can no questions to ask, because you have to spend more on insurance, your loan recovery, and all of that. So when you start asking these questions, the engineers will begin to be like, how do they get to know this? They didn't know you've invested money in yourselves to attend trainings as this. Ladies and gentlemen, before I give you the good news, I would like to invite to address us concerning fellowship of the Nigerian Institution of Highways and Transportation Engineers, Engineer George Usonwu, Fellow of NSC and Fellow of NIHTE. Let's put our hands together for him.
Good morning. Good morning. Please permit me to stand on the existing protocol so that we can be fast. I just want to inform us that the platform for the application of NIHTE's fellowship is already open. So now that you are here, please take the advantage to go to the admin there and collect a form. We have 3 types of fellowship. The first is by invitation. There are about 15 years of experience. The details you will get there. Then we have the regular one where you have to submit a thesis or paper or your experiences, which has a later years of experience. And then finally, we have for honorary. You may not need to be an engineer. You could be also an engineer of other branches to apply for that one. So please, you take advantage of being present at this seminar to collect the form. When you are applying and when we are going to consider you, then we'll remove the charge for the form. But you have the advantage of picking the form free now and make your application. Thank you.
Thank you very much. Then please, when you pick the form from here and you fill it, put somewhere participants at managing road infrastructure assets for sustainability. That is an added advantage. Thank you. All right, ladies and gentlemen, the good news is this. Coffee and tea break is ready. Let's have it. Thank you. In 15 minutes.